Hi YouTube, my name is Yusuf, and you are watching one of my first videos in a while. So if you follow my channel, you might know that a few months ago I decided to stop making videos, and that because a terrible thing happened, which might be linked to my space weather videos, or rather Big Brother not wanting me to show certain things. So what I decided, so then I said I will delay my videos and take time to assess whether or not I will be making new ones or not, new videos or not. So what I decided is I will be focusing mainly from now on the weather rather than space weather, but that doesn't mean I won't post space weather videos. If something meaningful happens, a major CME or anything, which is meaningful, I will be making short space weather videos at that time, but I will not cover certain things, certain topics, which I believe are the reason for what happened a few months ago. So I will just be doing basic space weather coverage, like you might see in other space weather channels. And I won't do it each day. I will only do it if there is something actually to talk about. So what will I be focusing mainly on is, of course, the weather. And what I will show you is, of course, temperature maps. This is for example, the 3D map, which I found most useful. This is, for example, the Polar Vortex, and I will be talking a lot about this because, in my opinion, all that climate change that you are hearing is really just happening at the poles because they are moving. And as the poles are moving, you can see this here, for example, the center of the polar vortex is leaning towards the edge of Australia, and over here it's definitely not where it is supposed to. So in my opinion, the polar vortex actually follows the Earth's magnetic field, or the wandering thereof. And this is what's causing a change in climate, not a warming, but a change. And I will cover this in depth in my weather videos. So if you want to actually explore this particular simulation, and I strongly advise you can actually zoom that in, zoom that out. You can see also the currents in the world. You can do overlays, for example, the temperature. You can choose the surface. Here we see surface temperatures and the adjacent water currents. So you can actually see a lot of things, a lot of interesting weather related topics in this particular simulation, and check the data yourself. So what will I be exploring also is the Climate Reanalyzer website, because that's one of the best when it comes to viewing the temperature globally, but also the temperature anomalies that goes along with it. And I just recently discovered, when I checked it, that there's actually a new one, the total accumulation and precipitation. I found it very useful to view this. Well, at least I didn't, well, when I was making videos a few months ago, I don't think this particular one was on the list. So you can see a lot of things here. You can see the precipitation, the cloud cover. You can run actually the animation and see for yourself for the coming days, the prediction for the coming days. And you can do so for many things. Like I see here, precipitable water. How much water vapor, the concentration of water in the atmosphere. You can see, I believe, yes, the wind currents. This is the 500 millibars, for example, the jet stream thereof. The 250 millibars. Again, the jet stream, very useful. Look at here, for example. I just discovered something while showing this. So you see, this wandering of the jet stream is what's causing all the crazy weather. And it is related to the polar vortex, because the jet stream at the lower altitudes actually follow what happens on top of it at the polar vortex. But I will cover this in my weather videos, no worries. Especially when the sudden stratospheric warming happens, and lately in these last years it almost happens year after year. This, for example, is the temperature anomaly map of the region, on the Arctic region, and you can see here's one mean 60 degrees to 90 degrees, and I will quickly show you what that means. It means this region over here, the top at the Arctic. So these are longitude lines. Yes, longitude, the latitude are the vertical ones. So the horizontal lines are called longitude lines. And in these maps, basically they cover the region of the Arctic starting from 65 degrees, as we have seen, to 90 degrees, which is the top of the Arctic, as I have shown over here. And this is very useful to know what's happening. That was my my Samsung 21S Ultra doing a notification, so I had to dial down the volume because I got startled when it did so. So, yes. I will be showing and explaining these maps in depth, and while we'll edit, this is the geopotential height anomaly with the Arctic Oscillation Index. But let's go to the geopotential height. I have it somewhere over here. Yes, let's bring it back over here. So this again is the 65 degrees longitude to 90 degrees, so that particular part of the Arctic. And why is this so interesting? Because when it is a positive reading at the surface, we can then say that there is a negative Arctic oscillation. And a negative Arctic oscillation has implications on the weather. Let me show you quickly. So you see, when the Arctic oscillation is positive, there is a stronger another notification. Let's close that down. When there is an Arctic oscillation, a positive one, there is a strong polar vortex circulation. It is compact and closer to the Arctic, and this has implications for these so-called westerlies, which are then stronger, and we have warm weather and storms to Europe, because the warm air basically moves to higher latitudes. When we have a negative phase, there is basically the polar vortex basically stretches, and all the cold spills over, as you can see in these arrows, either to the United States or to parts of Europe, Eastern Europe, and Russia over Siberia. And at the time that we are speaking, it is actually negative, and that is a bad thing. Let me just go to my web links, because I think there is a better... Oh yes, here it is. Arctic Oscillation Index. As you can see, as of the half of December, it started to become negative. This has an implication. It's not really that negative. If it was -5 or to the 6, then we would already have cold wave, because in a negative Arctic oscillation, we do have, let me go to the Climate Reanalyzer to show you this. If I put the temperature anomaly map, so basically what happens, let me go to the beginning. When you have a negative Arctic oscillation, the cold tends to pour over Siberia, and then you have these easterlies, which will be pushing the westerlies back, and this is cold, dry air, which will be coming to Europe from Russia. And if I go to the temperature and show you, that's very nasty cold air if it ever finds its way to Europe. Think about 2010, when people died in Europe because of the influx of that cold air. So why isn't it happening already? Well, mainly, and I'm going back to over here, that's because of the polar vortex, which is actually at the time of speaking favorable for warm westerlies. So let me just put the wind overlay. Because of its position, which is over northern Greenland, you have this over here, this movement. And at the surface, they tend to follow the polar vortex. So we have strong westerlies because of its position and alignment. But if the polar vortex changes, and with the current the negative Arctic oscillation, we could already see cold weather spilling to Europe. And if a sudden stratospheric warming happens on top of that, this will fortify the influx of easterlies. But let's hope this is not the case this year, because that would be a perfect storm for cold waves over Europe. But for now, everything looks good, and if I look at the temperatures, because of that polar vortex, which is located where it shouldn't be, it is sending these warm currents, these warm westerlies, and as you can see, at some point we will have very nice weather. At least it is predicted. And if I put the temperature anomaly map, we can see not just here in the western part of Europe, but almost reaching to Russia. So we'll have to see how this develops further. So this is what I will be discussing mainly. And I will think for my first video, I will wait for the first week of January, because then the sudden stratospheric warming is more likely to happen first or second week, and it makes more sense to do that in the first week of January of the new year. So this, for example, again, this is the 1 millibar, and this shows actually the temperature. And if a sudden stratospheric warming happens, you can immediately see it over here. You just have to follow the red line, which show actually how much it deviates from the average. And I do believe this is denominated in temperature. And this is of a certain, yes, of the 1 millibar. So the temperature profile, according to the period of time of the year, follows a certain pattern, and when it deviates from that, we can conclude certain things. So this is very interesting to see, and you can actually check that in, let me go back to the Climate Prediction Center, close this a little bit, let's leave this one, it's over here in Climate Prediction Center. So basically almost everything, you can find it over here, what I'm showing you. I believe it is the global temperature time series, and you can actually choose which longitude you want to view. I typically only use the Arctic region, which is 65 degrees north till 90 degrees, but you can actually view even of the equator. You can actually view the whole world, the temperature, but it makes more sense to actually only view what happens in the Arctic, and you can choose between all these different pressures of air. I typically use the 1 millibar over here, which I showed you previously, and the 10 millibar, because these are the most representative of what happens at the top of the atmosphere. Now let me put that to the end, because that's not really weather, well, kind of weather related. Then what I will also be discussing once a month is, of course, the Arctic sea ice news and analysis, to show you how the Arctic sea ice is actually progressing, whether it is increasing or decreasing. And this is one of the best sites, the NSEDC, National Snow and Ice Data Center, to do so. And you can actually view this yourself. This is a summary, so it's very easy, very comprehensive, very easy to understand. So you can visit that, and I will leave the links below in the description box. As usual, I always do that in my videos. Okay, let's go to the next. Oh yes, I won't be doing that systematically, but especially now, since we are in the winter, I will be discussing Arctic sea ice, the sea ice temperature, sea ice concentration, etc. And this is one of the best sites to do so. For example, this is the sea surface temperature map of the Arctic region. What do we have next? The sea surface height, I believe, yes. There is also the sea salinity map, if I'm not mistaken, over here. as you can see, the salinity of the seawater, etc., etc. The one that interests me the most is actually these two, the sea ice concentration and the sea ice thickness, especially the sea ice thickness, because you can actually compare them to previous years, but I'm not going to do this now. But if you go actually to the archive, let's take for example 2014, and let me just show almost the same data as today. You see, you can actually view the sea ice thickness of previous years and see how it changed over time. It is of course declining, as you can imagine. What I will also do is review, when it is published, the PDF document about the ENSO cycles, and this is the conditions of La Nina and El Nino. So basically sea surface and sea depth temperature profiles, which actually gives the index of whether or not we are in a La Nina phase or El Nino. And this is very important because La Nina and El Nino have different patterns. As you can see here, we are clearly in a mild La Nina pattern, and it has its own implications when it comes to the weather. And when I will make my videos, I will certainly put the implication of a La Nina. And there's also, if I'm not mistaken, yes, this is a very good summary of actually the values, historically, the values, the ENSO values, and I strongly suggest that you actually view these. And I do think they have the complete table back to, yes, 1950 can be found over there. There you will find actually the correlation between solar weather and El Ninos. And I believe so. Basically what happens is during solar maximum, the seas tend to be warmer. During solar minimums, the opposite happens. And this is a cycle of Earth absorbing energy from the sun and releasing it via El Nino and La Nina cycles. La Nina means energy is absorbed, and El Nino means energy is released into the atmosphere via the ocean. So there you have it. What else? Oh yes, so that's, well, there are a few other things, but I see that it's almost, that this is already a lengthy video, and I don't want to make it too long. So basically you have an idea of what I will be covering about the weather. There might be other things as well, as for example the amount of ozone in the air, etc. Other things as well, but mainly I will be focusing on the polar vortex, stratospheric warming, the vertical temperature profile of the atmosphere, etc. So yes, I want to show these. So when I will be making space weather videos, and I have to put that other one on top, the things that I will be discussing this time are just basic things. For example, if there is a CME or sunspot or auroral activity or whatever, I will make basic space weather videos. I will be showing events, and let's just take a look, for example, at the first month of the new year in January. We have, for example, on the 2nd and the 3rd, the Quantrides meteor shower, peaking at 40 meteors per hour. We have a new moon on the 13th of the new month of the year, and we do have Mercury at greatest eastern elongation, and this is important if you actually are a stargazer, if you have a telescope, because then I see the planet Mercury reaches greatest eastern elongation, blah 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 blah. This is the best time to view Mercury, since it will be at its highest point above the horizon in the evening sky. So there you have it. So I will be covering celestial events. And at the end of my space weather videos, if you remember, if you are one of my followers, I will be talking if something happens, if a volcano happens to blow, show you that on the webcams, especially on Iceland. What I will be talking is when there is an earthquake, show you if there is an event. And by the way, if you are familiar with the National Data Buoy Center, a tip that I might give you is to put it on tsunami, to put all the others away if an earthquake, major earthquake happens, because otherwise it will be clogged with other buoys, and that's not really good for visibility. I will be covering the Yellowstone, of course, as usual, because that's one of the most dangerous, if not the most dangerous volcano in the world, and see if it is still sleeping as it is supposed to. I will be covering earthquakes, of course, when CMEs happen, when there is space weather, active space weather, of course, there will be earthquakes as well. And that'll be mostly it. I might discuss other things like meteors or stuff like that when that happens, or asteroids, but it's dependent on the actual event. But mostly it will be basic stuff about space weather. Because I do believe that whatever happened a few months ago was because I was going much too deep into these certain subjects, especially things like the electron belt, the Van Allen belts and stuff like that. Those simulations from the magnetosphere. All that kind of stuff, I will not do that anymore for my own security. So, this is it, people. Oh yes, philosophical quotes, as usual. Let me see. Honestly, I don't know what was the last one. I would have to check my videos. Let's do that quickly. That's not my video. Let's go to my channel. Blah 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 blah. My channel. So which one was it? Videos. Must be this one. Oh yeah, so if you're wondering what probably caused a few people, or should I say Big Brother, to do what he did a few months ago, well, would be that kind of stuff. Major anomaly in the magnetosphere, stuff like that, which I will not cover anymore. So, what was my last philosophical quote? He who lives beyond his means forfeits respect and loses his sense. Wherever he goes, he will be recalled as a knave, and women will hate him. So let's see. He who... If I can find this very quickly. Oh yes, he who intends to... No, it's not that one. No, man. Oh yes, he who lives beyond his means forfeits respect. So I was at number 60. So let's go to 61. Poverty without debt is independence. So debt is clearly the real poverty. Whether you have money or not, if you have a lot of money but you also have lots of debt, then in reality you are not rich at all. You are indeed a slave and poor. So people, don't put yourself into debt, because that is the real poverty and slavery. This is it. Thank you for watching this lengthy video, which was just an introduction to what I will be posting into the future. Thanks for watching. Don't forget to hit the like button if you actually liked what you see. And I guess we see each other next time for my first weather video, or space weather video, if something actually happens in space. Thanks for watching, and we see each other next time. Bye bye, everyone.